Thank you. Thanks for coming to my talk. I'm very glad to be here. Thank you, conference organizers. And this talk is going to be good because it has alliteration in the title. That's always a good sign. So hopefully we get to live up to that. So before we get started, let's get into introductions. You know, who, like an owl, who, haha. Anyways, my name is Aaron Turner, like I was introduced. I go by Torch2424 on the internet. I made that name when I was 6 and it just kind of stuck. So here we are. And these are some of the things I do. I'll be getting into these in more detail later, but I'm a member of the AssemblyScript team, which is a TypeScript-like language to WebAssembly. Doesn't mean you can just take a React app and compile to WebAssembly, but we'll talk about them a bit. I'm the creator of WasmBoy, which is a Game Boy emulation library written in AssemblyScript for WebAssembly. So you can play essentially Game Boy ROMs on your web browser. I also created Wasm by example, which is kind of like Go by example, where it's bite-sized examples that you can just copy and paste for getting stuff done in WebAssembly. I made with WebAssembly, which is a showcase of projects that use WebAssembly to perform application tasks and things. And then I work at Fastly on their WebAssembly efforts. So using WebAssembly in like a serverless context and running applications on the web or on the edge. So what are we talking about today? What's our agenda? Today we're talking about budgets, but what kind of budgets? We're gonna be talking about the budgets of our users, such as like financial budgets. We'll be talking about resource budgets. For example, how much can a device accomplish with its resources? We will also be talking about performance budgets, as in measuring how slow or fast we want to allow our software to be. And then we'll be talking about building for these types of budgets, like what tools and technologies can we use to help us achieve our budgets that we've now defined. One of these tools we'll be talking about is WebAssembly. WebAssembly is relatively new. It's a portable binary format that runs on the web in both the browser and the server. We'll go into this later. We will also talk about web workers, which is kind of like threads on the web for multi-threading. And then we'll be talking about service workers in PWA, in which in our case, we'll be mostly focusing on how we can use these for an offline web. But first, I want to talk about people. And to start things off, we're going to start talking about the next billion users, or NBU for short. The next billion users are commonly known as the people who will be coming online in the near future. By becoming online, this can be through a smartphone, a low-powered laptop, or etc. And it may or may not be their first experience with technology. And NBU is a very hot topic. We got Google talking about it. We got Facebook planning for it. We have Microsoft researching it. We have books on Amazon about it. We have TechCrunch asking questions about it. And as you can see, this is an actual hot topic. But let's dive deeper into one of these resources and see what they have to say. We will be showing quotes throughout the slides, but I'll summarize them. This is a quote I pulled from that Google article I just had a screenshot of and showed earlier. And the quote explains that NBU users have a mobile-only mindset, which means they kind of only have access to a mobile experience when they access the web or technology and things. They have this ubiquity need for computing, as in they want their apps everywhere in terms of device, like on every device they can run it on, and in terms of location. And they want their software localized to them. By localization, the article is speaking about language, but I'll explain how this also applies to performance. Another quote I pulled from the same article mentioned where these NBU users are. And if you look more into NBU and the conversation around next billion users, it really focuses on areas like Brazil, China, India, and Nigeria. And 100%, these are great areas to focus on, and I think there's definitely problems there that need to be addressed. But what if I told you that NBU users don't only exist overseas? And I'd even argue that they exist in tech hubs like Silicon Valley. I want to talk about poverty in the United States of America. But poverty is a very strong term. What are we talking about here? Well, if we Google the definition of poverty, we get this. And what I'd like to highlight here is that poverty is the condition of a person who lacks financial resources for a minimum standard of living. So let's use the poverty line as our base for financial resources, kind of like this line that the government or US Department of Health and Human Services will set that kind of says, hey, if you make about this much, you're probably in poverty. So in 2015, for a family of 4, if you made less than $24,250 US annually, you are in poverty. But how many people is that? That's 43.1 million people in the United States of America, 13.5% of all people living in the United States of America that are living in poverty. And if you take a look at California, which probably has the largest tech hub in the world, 6.25 million of people living in California, or 16.5% of people living in California, live in poverty. But why do I care about poverty? Because I was one of the people living through it. After I went to college, I learned and understood more about my family finances from student financial aid applications. And in 2015, my family made $11,205 US. And we were a family of 7 living in a 2-bedroom apartment. And that's well below the poverty line. So going back to our 3 points, mobile only, ubiquity, and localization. I heavily relate to the MBU experiences, and I feel like an MBU user if I was not one already. People in poverty really experience the same issues with the web, and there's a greater community that is in this conversation, I think, that are also included in these issues. So to show this, I'd like to share some of my early experiences with the web. So I first got online when I was about 6 years old. I'm definitely young, but I experienced the end of the early web, I would say, or the tail end of it. I heard lots of dial tones when logging online and things like that. I got all my internet access from free trial America Online CDs, and I would repeatedly just cancel my account right before the month was up of the free trial, and then just get a new CD to have internet access at the time. And then my mom couldn't afford a good computer, but it was around the same time when you kind of needed a computer to just do basic tasks that you need to do around your life. So what we had was a Windows 95 e-machine, but it was around 2003. This wasn't my computer, but it looked equally disgusting as the one that I'm showing now. So my first experiences with the web were 2 web games, really. Disney's Virtual Magic Kingdom and RuneScape. They were both very community-oriented type games that I would often play with my friends that I had at school and things after school. But I very distinctly remember that my computer just could not run Disney Virtual Magic Kingdom. Like it would just try to load the page and just load forever. So the only time I could actually play it was when I was at a friend's house. And for me, this game was not ubiquitous. I couldn't run it on all my devices. I can only run it on devices I had limited access to, like my friend's computer and things. And my computer could barely run RuneScape. Like if I let the page load for about 15 minutes, I could then start to use the chat box, but I definitely couldn't like actually play the game and go on quests and do things with my friends that they wanted to do. So again, I never really invested time or money into this game because I could only play it on higher end devices that I had very limited access to. It wasn't ubiquitous. But the price of RuneScape was only about $5 a month. All my friends on RuneScape were members, and I wasn't. It wasn't because my family couldn't afford the $5 a month. It was just we could not afford the upfront cost of a brand new computer so that I can actually get the value out of being a member for this service. So I feel like there's a lesson here. Should we be building our games for Windows 95 Internet Explorer? No, that's not the lesson. But the lesson is that we should really be making our websites or applications ubiquitous. The fact whether or not your application supports a device in terms of resources and performance can affect whether or not a user will join your application, subscribe to a service, or even buy your product in general. Next, I want to talk about some of my other web-enabled devices. My first smartphone I got when I was about 14, and then the best cheap phone I can get at the time was about an LG Optimus V for $150. And I used Virgin Mobile at the time because they had the best prepaid data plan for the price. But when I heard this, you know, my natural instinct, even looking back, was like, oh, okay, cheap phone nowadays are considered like $300. But a renewed Samsung Galaxy S7, which I also, looked at, is about 1% of all mobile devices in the US right now, which is, I think, the 7th most popular phone in the entire US. It's $150 if you were to buy it today. And so that $150 price range is still very relevant as in terms of like getting a smart device. The only other device I owned for accessing the web was my cheap netbook. I remember my mom saved up for about a year, I think, to buy me a $300 US dollar one for my birthday. I needed it for school, but also just general computer stuff as well, just like playing League of Legends and other MMOs at 12 frames per second, because that's what you do when you have a netbook when you're a kid. But my home internet was never a given for me. Depending on whether or not we could actually afford home internet, I'd have home internet access. So what I'd have to do is hotspot my phone against the phone plan terms for home internet when I had no home internet access. So my data plan for mobile also became my home internet, and I would just share the hotspot for both my phone and my netbook, and that's how I got all my internet access for the month. And in fact, this is when I'd say around the same time I seriously started developing. I was really into rooting Android phones, and I started playing around with Linux, and so I can modify scripts and ROM images to decompile APK files and build my own Android ROMs that I could share online. So I really learned, how to become a developer, Linux basics and things like that. On my phone hotspot, like I was downloading scripts and things through that. So when you're downloading like literally Linux images that are like gigabytes, you quickly run out of data for the month. So what ends up happening is that you become extremely reliant on free Wi-Fi hotspots. So what I would do is I would go to places with free Wi-Fi. I would download development stuff, applications, music, games, even read news, because when you open up a bunch of tabs, like all that JavaScript that's getting loaded, like, you start to notice like, okay, if I use this site, it's, eating up my data plan. So I became heavily reliant on my phone and stay to use the web. Like my phone was just what I had, and that's how I accessed the web at multiple points in my life. So what's the lesson here? Should we be testing production on McDonald's free Wi-Fi when it's safe to go back outside? Actually, yeah, maybe we should. Design your website or application with a mobile-only experience in mind. Whether that be making it responsive, reducing your bundle sizes so users aren't encouraged to use it later, or even a completely different version of your product that's hyper optimized for mobile. Some people really have to depend on their entire web access on just their phone. So it could definitely help a lot of your potential users or your current users immensely and encourage them to use their application when they want to, not when they can. But I really don't want to talk about myself all day. I really want to focus on other people actually, in ways that I've seen them experience the web. And the most notable story I have about this is probably about Obama. I want to talk about Obama phones. Obama phones is kind of this slang term for a free government cell phone and phone plan. The program wasn't started by Obama, but it was rapidly expanded during their term. And the program is formally known as Lifeline Assistance. So let's take a look at what this plan provides. This is one of the many plan providers that you can get that goes through Lifeline Assistance. What you get is a free phone, minutes of talking, minutes of text, or talking and texting, and you also get 1 whole gigabyte of data. And if I'm using my phone hotspot as my home internet, like I mentioned earlier, which a lot of people do, and actually my whole family did at some point around like 2011-ish, you get about 1 hour of Netflix for the entire month and your data plan's just done. So it gets pretty dicey, I guess you could say. So let's take a look at how popular Obama phones actually are. And this picture is a picture in San Francisco, like I said, big Silicon Valley tech hub, and it's in the Tenderloin. The Tenderloin is what you could say is maybe the low income district of SF. And here we have an Obama phone tent. So they're offering people to line up for the program and get signed up and things. And I also see these tents all over Long Beach where I live, like in the downtownish area. So it's a very popular program. So let's take a look at the performance of these types of devices compared to higher end devices a lot of people here are probably using, such as like an iPhone X and things of that sort, or iPhone 10, iPhone 11 things. So this is a slide from Christopher Baxter's and Malta Ubel's JSConf US 2018 talk. And it shows the Nokia 2 at the bottom, it's that blue line there. And it's very popular in the next billion users market, and it has a very similar performance to these Obama phones I'm mentioning. And you can see it's just getting completely just wrecked in single core performance by a lot of the devices that we use, such as the iPhone 10, iPhone 11, which is most web apps are going to be dependent on single core performance because JavaScript is mostly run in the main thread unless you use web workers, which we'll be talking about later. But let's expand on this. Let's look at the performance of devices I've shown throughout this talk so far. So let's take a look at that Samsung Galaxy S7, which I said was 1% of all US mobile devices, 7th most popular device for going on the web with, according to Device Atlas. The S7 is 0.6 the performance of an iPhone 10 and 0.38 the performance of an iPhone 11. Even the Galaxy S8, which actually is 2.98% of all US mobile devices, and I'm pretty sure Device Atlas claims to be the #1 most popular web device for Android, is just getting decimated by performance benchmarks of these devices. So let's take a look at these Obama phones I'm mentioning. Let's see what types of devices I can get in the program and things. So if we want to splurge a little bit, and instead of getting our free phone, we scroll down and choose a device for $130. Let's pick the Moto E5 Play. I dare to say if you have an Obama phone, it's probably a miracle that you're using the web. If you splurge and pay for a device on this program, you're getting 1/10 of the performance of an iPhone 11. So whatever things bother you about the web or your websites that just kind of slightly annoy you, try to imagine what that must be like to have it 1/10 the performance of what you're currently experiencing that you already don't like. It is just almost unimaginable. So this is why performance budgets are very important. It kind of automates the process of having to test on a low budget device and helps you from becoming too slow for an audience that you didn't quite know that you were building for. We should still be testing on low budget devices. Definitely should still be testing on these devices, like actually hold them in our hands and test. But performance budgets are really great for keeping a reality check and just keeping, as your code's being built, checking in on making sure that it's not getting too out of the way of what you want it to be. And if possible, you should set these up from day one because it's a lot easier to just build and have these in mind rather than trying to go back and retroactively fix per a budget. And one more story I have about this is Max Bittaker is an awesome friend of mine. And they made a WebAssembly game called Sandspiel using Rust and things. And from this, they found some really great performance wins in their app. But they didn't have a performance budget. So they put the performance into scaling their game. And by scaling, I mean, they have like these maps and they're maybe about 200 by 200. When they use WebAssembly, like, oh, wow, I have all this headroom now. Let me make the map 300 by 300. So they tested this on their iPhone. So when people started building maps and things in their game, they started saving them to the database. And now that the maps are saved to the database as 300 by 300, when they realized, oh, I've been testing this on my MacBook and my iPhone, but what about all my users that don't have those devices? They can pretty much no longer play the game because the map just doesn't have the performance anymore. It's too big for what they can render. And this is something they can't undo. Like, it's stuck. Like, they can't go back and re-architect according to this. It's already done. So from this lesson, so that I could share here that just because you find more headroom in your application doesn't mean it always means you can add new features. You want to have these performance badges set up because you never quite know, like, okay, I want to build this new feature that depends on more performance. You want to make sure that you're keeping in check with your performance expectations for lower end devices. So what's the point here? Should we be testing on Obama phones? Yes, that is definitely the point here. We need to localize our applications for certain communities. We should reach out to these communities, learn their terms like Obama phones, and make sure our apps work for their unique characteristics, whether that be language differences, ridiculously slow CPUs, or even the digital divide, which is when tech was too expensive before, and this is now their first time with technology, and things that are second nature to us isn't for them. So taking a look here, we can see that there are three main points that I'm bringing up here: ubiquity, mobile-only mindsets, and localization. They're very common in overseas next billion users, but also local to the United States, low-income next billion users as well. But how can we solve them? Well, there are technologies today that we can work on all modern browsers that we can use. First, let's take a look at my personal favorite, WebAssembly. WebAssembly is a universal low-level bytecode for the web. Because of this, WebAssembly is great for running logic-heavy tasks such as image manipulation, physics for games, and heavy math computations. But why is it great for this? WebAssembly offers predictable performance. JavaScript, when it's run on a browser or Node or whatever JavaScript runtime you're using, it needs to be parsed and then evaluated and then recompiled in a JIT compiler many times. And because it's being JIT compiled, this can get extremely fast or fall off that fast path when it makes the wrong assumptions. But bytecode, it offers a more consistent, predictable performance that won't fall off this fast path because it just gets run straight through and it's compiled and shipped down that way. And one more thing, WebAssembly is extremely portable. You have WebAssembly running on the server, so because of this, you can take code that's running on your browser, move it to the server, or vice versa, whatever you need to do. You can be running it using Node outside of the browser, and it can also be bundled into NPM and your NPM modules. You can also use WASI, which is the WebAssembly system interface, and allows you to run applications in your system, like on your system with a runtime like WASMtime. And what that's going to let you do is do things like file access, and there's currently proposals for things like network access, things of that sort. And you can even embed these runtimes, these WebAssembly runtimes like WASMtime, into your Python server or Rust server, whatever it may be. That way you can have like maybe a request that comes in, run a WebAssembly module that can then be shared in multiple parts of the application, and then just use the runtime there. And this is really good for your budget. I didn't mention that at the beginning, but this is something you can think about. You can write your code once and use it in multiple places using an appropriate runtime in the right place. Google Earth gave a WebAssembly SF talk about this. They used WebAssembly to make their code portable across the web and many other applications and systems around Google. And it's a talk I would definitely recommend. If you search on YouTube, you could find it. So WebAssembly sounds really cool. How do we get a running start with it? There's this website, WASM by Example. It's made by me. Essentially, it's like Go by Example, bite-sized, copy-pastable tutorials and examples that helps you learn the concepts in a language of your choice that you can then go and like understand things like linear memory, things of that sort, and then build on top of those concepts with tools that make it a lot easier and convenient in your application. And there's a lot of languages that are outputting WebAssembly right now. The most mature of the three are AssemblyScript, which is that TypeScript-like to WASM language. Like I said, I'm on the team for it. What it means is that you can't just take a normal JavaScript or TypeScript application or TypeScript React application and just compile it to WebAssembly. What it is, it's a superset of TypeScript. It has its own little quirks and things, so you can't just take TypeScript off the shelf. But it definitely has the same TypeScript workflow in which you use NPM. You can use NPM scripts. You have a package JSON, and it definitely looks and reads like TypeScript. And in fact, there's a TS config that just does a lot of the funny stuff. Now, I've been able to compile AssemblyScript applications using the TypeScript compiler, so you can definitely, it feels really natural for a TypeScript developer. It has some really nice tooling, such as Aspect, which is a mature testing library for AssemblyScript and things of that sort, and also ASBind, which is something I wrote that allows you to pass data types between the browser and WebAssembly really easily. Another language, Rust, has really nice tooling, such as WASMPack for bundling your Rust WASM modules into NPM packages and things. And it's a very mature language, And there's also Emscripten, which is a toolchain for C. It's extremely mature. It evolved from ASM.js, which was a superset or super optimized version of JavaScript that turns C and C++ into WebAssembly. So next, let's talk about web workers. Web workers is threads on the web. It's really good for parallelization and multi-threading, things of that sort. And Performance Matters is an awesome talk by Emery Berger. I definitely say watch the full talk for all the context here, but the idea is that Moore's law is slowing down. We can no longer keep increasing clock speed per the transistors. The reason for this is that each single core of a CPU just gets too hot and we can't find a way to dissipate the heat fast enough to keep increasing the clock speed. Thus, we had to start multi-core or putting multiple cores on a CPU, but a lot of apps don't really take advantage of that. The problem isn't unique to the web. It's a problem for computing in general right now. So because of this problem, we start to see this idea of a UI or a main thread. Where the user interaction should happen is one thread in which all the UI and things interact with one another. All of your business logic and computation should happen on a separate thread. And I have a friend, Surma, that is working on resources to help this idea for the web currently. Surma has been writing some really interesting blog posts on the topic, and I definitely recommend you read their work on web workers and some of the ideas they have around this main thread and moving logic off of it. They also built Comlink, which is a wrapper around web workers that provides a very clean API. It makes isolating logic that's currently on the main thread and moving it onto a web worker. This even allows passing callbacks and functions into the worker, which is extremely difficult to do if you're not using Comlink. And I think it's a great place to get started with web workers and really making your apps a lot more smooth on their UI thread and moving all your business logic off of that. The last technology I want to talk about is service workers, but we'll probably talk about them more broadly as progressive web applications as well. What a service worker is essentially it's a client-side proxy. In other words, whenever your website makes a request, a service worker can capture that request and return a cached version of the asset or whatever you're requesting for, or just do anything really special with that request. But this is interesting for us because it enables offline access. Like we were saying earlier, if you run out of data for the month, if you have a service worker, you can maybe get your way around that using offline access and things. And this is huge for people who want to conserve data, who run out of the data plan or don't even have a data plan. They only use those Wi-Fi hotspots I was mentioning for communication. It's also really handy for plane rides and tunnels, even if you aren't in those financial situations or whatever your phone plan may be. And there's a variety of tools for service workers and PWAs. Workbox is a tool for generating service workers. It has a lot of good documentation. And what I really love is that they have a lot of good visualizations to explain what's going on with these requests in the background. A lot of framework tooling will PWA by default, such as Preact CLI and Create React App. And I personally think framework tools might be a great way to get your feet wet with a PWA before committing to one on your production application. So it's a nice way to play around before you go all in. Let's highlight some of the good PWAs that you can play with today. Vaporboy is an open source PWA side project of mine. It's powered by that WasmBoy, which is that Game Boy emulation library that I wrote in assembly script. It uses WebAssembly to run the actual game ROM emulation, and then runs that WebAssembly core inside of a web worker. That way, the actual UI you're interacting with, such as the buttons and the menus and things, stay really smooth, even though you're running the game on a separate thread in the background, and gives really good performance. And it works offline because it's a PWA built with Preact CLI, so I got a lot of those service worker and offline access for free using my framework tools. And Recipe Sage is another great PWA I love. It's built by a close friend of mine, Julian Poyero. It has a custom-built service worker in Workbox, works offline, and it's really good for grocery stores with bad connections, or if just maybe your internet goes out and you just want to start cooking because you're bored or whatever it may be, and you can still access all your recipes and things. So that was a lot of information. Let's wrap things up. Here are my main points. Normally this is a slide I would say, if you like taking pictures of a slide, now's the time to take a picture. But since we're not in person, now's a great time to press print screen if you like printing screen of slides. But yeah, budgets exist everywhere. They are not just overseas, they are overseas, but low-income areas, rural areas, they exist everywhere. Everywhere you go, your application needs to kind of conform to these budgets of people that your users are going to have. Create performance budgets. They give really good reality checks by your app as you're building your app, and it's really handy to have. Use WebAssembly and web workers and service workers. They really help you build for budgets. And more headroom does not mean more features. Now that I've given you the keys to the kingdom, it doesn't mean that it's going to be like, oh yeah, like I have the keys now, I can just go and like ruin my performance. Like definitely you want to keep those in mind now that you have these tools to like start building greater features for your application. Here are my major resources for WebAssembly. WasmBoy example is just those bite-sized examples, really help you learn WebAssembly if you're interested in it. and your favorite language. If it compiles WebAssembly, which it probably does, has language documentation usually that you can refer to. Web workers, please check out Comlink and Surma's blog posts about web worker content. Service workers, there's Workbox, like I mentioned, and your framework CLI tool probably has PWA information about it. And I want to give special thanks to the reviewers such as Marcy Sutton, Brendan, Kareem, Nana, Surma, Henry, Ben, and friends and family. The AssemblyScript team has been nothing but great. They're looking for sponsorships, or if you just want to get involved, we just started weekly meetings, definitely recommend those. The WebAssembly community has been nothing but just open arms and nice to me. I love them so much. Surma and Max for letting me share their stories, and then my friends, family, my partner, my mom, my dad. So yeah, thank you very much for the conference organizers for having me. Thank you very much for watching. Please reach out to me over Twitter here at the conference when we have the Slack. Feel free to ping me. And thank you very much. Enjoy the conference.